Okay, so now we're going to move into objective 3, and it's going to build on the previous two objectives. In objective 3, what we want to learn to do is to relate grams of one compound to grams of any other compound in the same chemical equation. Before, we related moles of a compound to any other compound in the same equation. Now we're going to relate grams. So let's dive into it. Here's a question. How many grams of oxygen are needed in order to burn 23.5 grams of acetic acid completely? So here is our formula here. We've got our acetic acid. We've got our oxidizer, oxygen there. It's going to produce carbon dioxide and water. What is it that they have given us? If we read that, what are we going to say is our given? And what are we going to say is our wanted? Go ahead and try to answer that. So given is 23.5 grams of acetic acid. I'll just pull this back so we can see that part of it. That's our given. And what is it that we want? Well, on this side of the equation, we want the grams of oxygen. So we'll pull this back so that we can see grams of oxygen there. There we go. So now we know what we're starting with and where we're going to end up. How do we fill this stuff in the middle so that we get from where we're starting to where we want to go? That's the goal here. Well, let's start off with, we can't say anything about grams of acetic acid as it relates to grams of oxygen. We can say something about moles of acetic acid, because I know 1 mole of acetic acid combines with 2 moles of oxygen in order to form carbon dioxide and water. So I need to convert my grams of acetic acid to moles, because that's what I can relate to. And you guys have done that several times just in simple calculations. The way you do that is you add up the molecular mass of this compound here. 2 carbons, 4 hydrogens, and 2 oxygens, and you come up with a molecular mass of about 60. And what that means is that if you have 60 grams of it, you have 1 mole. So now we have calculated, if we just take 23.5 and divide it by 60, that'll give us the number of moles of acetic acid we have in 25 grams. That's why that moles is on top there. But that doesn't give us everything we want. Now we have to relate moles of acetic acid to moles of oxygen, and that's pretty easy. Every 1 mole of acetic acid relates with 2 moles of oxygen. So here I now have a relationship from the acetic acid. They gave it to me in grams, but that's what I'm starting with, and I'm relating it to the objective, the oxygen. So if I were to simply just take 23.5, divide it by 60, multiply it by 2, what that would give me there is the number of moles of oxygen that are required, but it doesn't give me the grams of oxygen, which is our goal. So in order to find the grams of oxygen, I'm going to say that there are 32 grams of oxygen for every 1 mole of oxygen, and that will give me my get that out of the way entirely there. There we go. Now, if I multiply this through, 23 times 2 times 32 divided by 60.052, then I end up with a mass of 25 grams of oxygen. So you can see that what we did here was merely just start off with our objective 1, identifying what we're given and what we wanted, and then our objective 2, relating moles of acetic acid to moles of oxygen, and then now we've added one more objective, relating grams of one compound to grams of the other. Let's look at another example. We're going to look at this one. It says, how many grams of oxygen will be produced when 15.0 grams of potassium chlorate are consumed? So potassium chlorate, that's this molecule right here. And you can see that oxygen is a product. As you heat potassium chlorate, oxygen is naturally evolved from it. So what have they given us, and what do we want? Well, we'll put our given over here, and we'll put what we want over here. So over here, on this side of my page, I'm going to say they've given me 15.0 grams of potassium chlorate, And over here on this side, I'm going to say what I want is grams of oxygen. And then I have to figure out how to navigate from the grams of potassium chlorate to my grams of oxygen. And we go about it doing it just the same way we did up here. I don't know anything about relating grams of chlorate, potassium chlorate, to grams of oxygen, but I do know something about relating moles of potassium chlorate to moles of oxygen. So if I can convert my grams of chlorate to moles of chlorate, then I can relate them to how many moles of oxygen, and then I can figure out how many grams of oxygen. So to do that, we'll go to our periodic chart of the elements, add up the molecular mass of this compound, so see what potassium weighs, what chlorine weighs, and 3 oxygen weighs. And when we add all those things up, we come up with a molar mass for potassium chlorate of 122.55. That's 120.55 grams of potassium chlorate gives me 1 mole. So now, if I were just to multiply those two things out, that would tell me how many moles of potassium chlorate I have in 15 grams. Of course, that doesn't get me very close to my answer. Now I need to relate moles of potassium chlorate to moles of oxygen. And that's a pretty simple ratio, 2 potassium chlorate for every 3 O2. So I'm going to put that right here, 2 moles of chlorate to 3 moles of O2. And now all I need to do is find out how many grams of oxygen there are in that number of moles of oxygen. And to do that, I simply take the molecular mass of oxygen. So for every 1 mole of oxygen, there are 32.00 grams. And if I now multiply 15 by 3 by 32 divided by 122.55 divided by 2, then I end up with 5.88 grams of oxygen. So we have related grams of one compound, potassium chlorate, to grams of another compound, grams of oxygen. That's the strategy. Let's do 2 more examples, and then we'll move on to another objective. Here they're asking how many moles of sodium thiosulfate are needed to react completely with 42.7 grams of silver bromide. Now, this sodium thiosulfate is not a compound you've encountered before, but it is 2 sodiums, 2 sulfurs, and 3 oxygens. And here is our reaction. 2 moles of sodium thiosulfate with 1 mole of silver bromide will give us 1 mole of sodium bromide and 1 mole of sodium silver thiosulfate. All right, so that's what we've got here. What did they give us and what do we want? What are we going to put on this side as a given and what are we going to put over here as our goal? Well, we always start with whatever numbers they give us in the question. So we're going to start with 42.7 grams of silver bromide. We know that's what they've given us. And got to figure out, well, where are we headed? Well, we're going to moles of sodium thiosulfate. Now, the good news is this. I am going to have to go from grams to moles of silver bromide. But once I calculate my mole ratio of silver bromide to sodium thiosulfate, I'm not going to have to figure out how many grams I've got. I just want to know how many moles. That's pretty handy. So over on this side, I only need to figure out moles of sodium thiosulfate. And we go about it the same way we did up above. I know that if I have 42.7 grams of silver bromide, I can calculate how many moles that is. And I need to know how many moles that is because if I know how many moles of silver bromide I have a relationship of silver bromide to sodium thiosulfate in moles, but not in grams. So I have to go from grams of sodium bromide to moles of sodium bromide. And to do that, I'll look up sodium on the periodic chart of the elements, add it to the mass of bromine, and come up with the molecular mass of silver bromide. And that's 187.77 grams for every 1 mole. And if I just take 42.7 divided by that, that would tell me how many moles of sodium bromide I had. But I need to know now my mole ratio between sodium silver bromide, and sodium thiosulfate. And I know that 1 silver bromide relates to 2 sodium thiosulfate. So I can add that to my equation now. 1 mole of sodium bromide relates to 2 moles of sodium thiosulfate. And because I only want to know moles of sodium thiosulfate, I don't have to now figure out how many grams of it. I can just leave it at that point. And so if I take 42.7, divide that by 187.77, multiply that by 2, what I come up with is 0.455 moles of sodium thiosulfate. So I have, in this case, related grams of one compound to moles of another. Now in that same reaction, let's do one more problem and then we'll move on to our next objective. We want to know what the mass of sodium bromide is that will be produced from 42.7 grams of silver bromide. So what are we given and what do we want? This is what we're given, 42.7 grams of silver bromide. So write that over here on this side. And then off over here, our target where we're going is mass. So that'll be grams of sodium bromide. So write grams of sodium bromide over there. And that's what we have here. And this is what we're going to have over here. All right. Now, how do I get from grams of silver bromide to grams of sodium bromide? Well, I do what we did right up here. I'm going to convert grams of silver bromide to moles of silver bromide, and then I can relate my moles of silver bromide to my moles of sodium bromide, and the good news is that's just a 1-to-1 relationship, so that's pretty easy math. And then I can figure out how many grams there are per mole of sodium bromide, and that'll help me calculate my grams that I have. So if I add up silver bromide, as we came up with there, I have 187.77 grams for every 1 mole. And I have a 1-to-1 relationship between silver bromide and sodium bromide. And the only next thing I have to do is convert from moles of sodium bromide to grams of sodium bromide. And to do that, I look up the atomic mass of sodium and the atomic mass of bromine, and that tells me how many grams there are of sodium bromide in 1 mole. So you can see how I could cancel out everything except for my grams of sodium bromide. Grams of silver bromide cancels with grams of silver bromide. Moles of silver bromide cancels with moles. Moles of sodium bromide cancels with moles of bromide. And that leaves me with grams of sodium bromide. And if I multiply that through, I come up with 23.4 grams of sodium bromide. And that is how we relate grams of one compound in a formula with grams in another. And I'm going to give you a worksheet where you can work on a bunch of these, but that's enough for now, and we will move on to our next objective.